Alrighty. Let's do it now. I was pointing to this earlier. I forgot about terminal velocity, so oh man, I just babbled on in that video for about 15 minutes. Now let's do friction. Okay, friction. So far, if we had friction, I gave you a number, just made up a number and said, here's the friction. We have to be able to calculate it. Friction is a bit of a pain. It's more to calculate in a problem, so we have to do more problems with friction. But let's go through what it is first. All right, friction. It's another one of those Italian words, yes, Italian, friction. So, friction. All right. Friction is a force, hence why we're doing it in the force unit. It is a force caused by contact between two objects. They can be two of the same material objects. Most of the time that's not true. It can be two different objects. Most of the time that is true. So it's a contact force. So you have to, so terminal velocity, air resistance, in the last video talked about that. Air resistance is a friction. As something moves through the air, it's hitting, it's a contact force, that is a friction. Friction is going to slow something down. That's what it does. It's called a dissipative force. Okay, so now friction, there are different kinds of friction. Sometimes friction is good. We want friction, and sometimes we don't want friction. Okay, whew. Friction was my friend at that time. Oh boy, you can't, if you don't have friction, you can't go anywhere. And if you don't have friction, wow, you can't stop. So starting and stopping, going around corners, we gotta have friction. It's our friend. I always thank friction at the end of every day. I sit down and I say, thank you for friction. Every day. I wouldn't lie to you. I'm not lying. I wouldn't, besides I'm standing, I'm not lying anyways. It's funny. Okay, moving on. So friction, sometimes we don't want friction though. Automobiles, okay, cars. You have an engine. The engine has pistons which move through in the cylinder. You don't want friction there. That would be a bad day for your engine. So you put motor oil as a lubricant. Okay, if you don't want friction, lubricant. And if I ask what's the most common lubricant, most people say motor oil. Wrong. Nature, think nature, lubricant, water. Yes, you know about hydroplaning, you do. So water is the most common way of reducing friction. Motor oil, of course, is the way you do it in an engine. But water in your engine, it's not gonna work. Don't do it, don't do it. Okay, so let's see. There are ways to reduce friction. So if you want to reduce friction, 1, lubricant. Water most common. 2, rolling. Rawhide. Moving up, moving out. Rawhide. Old TV show. I was always watching it when I was a kid back in the 30s. All right, so rolling friction. When I was a Boy Scout, not for very long, they didn't really want me to be a Boy Scout. That's a whole different video. Okay, story. We had to move this large crate of supplies back to camp. Long story. But we had to get out of the woods. So what did we do? Yeah, we found several logs and we were able to get on the log. We just pushed it along the logs. And we took one log and we moved it to the front of the box. I think we had 3 of them, maybe 3 or 4. And we were able to keep that thing moving along because we used rolling friction. And in a video earlier, not too long ago, talked about the cart, the wheel on the cart and the donkey. And the donkey can pull the cart because it has a wheel, which has very little friction. Rolling friction, muy poco. Okay? Sliding friction, muy grande friction. All right. So rolling friction is a way, and also there are things called ball bearings. Ball bearings are small steel balls. It depends, they can be different sizes, but usually they're about the size of a BB. A BB is about yay big. And what you do, if you need machinery to have moving parts that have to slide by each other, well, it's not going to be very good if they're rubbing together. It's going to cause heat and deform them in the machine dead. So you put little BBs, little balls, steel balls there, and slides right along. Yes, ball bearings. Okay, third way of reducing friction is material. Certain materials, and we're going to learn this very quickly, that materials are really important in determining how much friction. What are you talking about, materials? Well, think about non-stick cooking ware. It has Teflon. So Teflon would be a material that has been developed. Teflon. I'm going to put a little R for registered trademark so I don't get sued. Okay, by Dow Chemical. And that is very slippery. Slippery stuff. You put something on there, you want to dump it out, and from the pan, and whoop, comes right out. Because that material has very, very low friction. So materials are very important when it comes to lowering friction. All right, so this is different ways to lower friction. Then we have two kinds of friction that we have to know. So let's see. Friction. There is sliding, and there is starting. Sliding friction versus starting friction. And actually you know, but you don't know that you know, but I'm going to let you know that you know that you know. Yeah. Which one is greater? Which one is there more friction? Think about it. To get something to start or to get something to slide? You know the answer to this. You know. If you ever watch the... sometimes on Nessun, when they have nothing on Nessun, or ESPN, they have nothing else on to put late at night, they'll show these strongest man in the world competitions. And they always have a pulling contest. They're pulling a bus or a tractor trailer truck or a train car or something, and they harness these guys up, and they give them a time to pull this thing 50 meters, and they want to know, who can do it the fastest. So ready, set, go. Spleen, pancreas, hernias all over the place, but they get the job done. But it's a lot. Once they get it going, they tend to keep it going. It's the beginning where they're all grunting, but once they get it going, it's easier to keep it going. There's your answer. You knew that. You did. Starting friction is greater than sliding friction, and we do have to differentiate between the two when we do friction problems. Are we getting it to start, or are we getting it to slide and keep going? Different. This one is sometimes called static because it's not moving and you have to start. The word static means, thank you, that was my static impression, not moving. Sliding, kinetic, sometimes called kinetic, and the word kinetic means motion. So this is kinetic friction. Okay? All right, so we differentiate between the two. All right, I think we're ready for the equation. I think we're ready for the equation. Remember, at the beginning of this unit, I said there are only 3 equations, and they're all small and easy. And here is your third one, the friction equation. FF equals Fn times mu. That's what the kitty cat says. Force of friction equals normal force times coefficient of friction. Normal, what's that? As opposed to the abnormal force? No, remember we talked about, if you watched the video on inclined planes, then you would know what normal force is. But for those of you who didn't or forgot, I'll review it. So you got box on table. Box on nice, horizontal, high quality, made in America table. The weight vector goes straight down like that. The weight vector is a normal force. It's a normal force. I thought it was a force of weight. It is, but it's also a normal force. Well, why? Because normal in math means perpendicular. And to the surface, that weight vector is perpendicular. That's what normal means. So in order to figure out how much friction this box would have on the table, we would have to know what the normal force is. In this case, because it's horizontal, the weight vector is the normal force. In this case, they're the same thing. Okay? So when you have a horizontal surface, okay, this is important, people. Wake up, stop drooling on your table. Okay, are you awake? All right, focus now for a minute. The weight vector and the normal force are identical, they're the same thing, on a horizontal surface. You gotta remember that. That's it, that's all you wanted me to remember? I'm going back to sleep. Okay, all right. So that, a lot of times, is weight. So why don't you just write the equation for friction like this? Put Fw times mu. Because not always is the normal force the weight vector, not always. On an inclined plane, here's my inclined plane, there's weight, there's the normal force. They're not the same thing. So on a horizontal surface, they are, but on an incline, they are not. So be careful of that. All right, so we have to use Fn and not Fw for our equation. Usually it's Fw, but not always. All right, what's mu? Mu is called the coefficient of friction. What does that mean? This has to do with the materials. Materials. We are living in a material world, and I am a material girl. All right? Okay, all right, I am. Sometimes I get in touch with my feminine side. I'm a material girl. I should write music because it's really good lyrics. Just gotta write this stuff and get it out there before somebody steals my lyrics. All right, so materials. This is all about the materials. Well, what does that mean? What does that mean? That means that if I have sandpaper rubbing on a piece of sandpaper, that would be a real hard thing to do. Don't believe me, try this at home. Take a piece of sandpaper and try to rub it along a piece of sandpaper and see how that works out for you. Not very well. Well, what if I took an ice cube, and I slid it along linoleum floor? Well, that certainly is going to be a lot less friction than a piece of sandpaper on a piece of sandpaper. So this has to do with what two materials that we are rubbing over each other. Okay? That is what it's all about. Now, there are books thick with coefficients of friction between two materials, because imagine all the materials there are in the world, and imagine the combinations of rubbing one material on another. Common things would be like rubber-soled shoes. I couldn't get that high enough, and I'm not going to try it again. I'm going to pull something. Rubber-soled shoes on linoleum floor. Okay, that's common, right? Because a lot of people walk on floors. Or maybe a piece of wood, a block of wood on a plastic tabletop. There are common combinations, but there's a lot of uncommon combinations out there. And so people have actually done this. Physicists have actually done calculations for coefficients between two materials. And you need those numbers. Now, usually, the coefficient of friction number is between 0 and 1. Between 0 and 1, a scale of 0 to 1. The higher, closer to 1, the greater the amount of friction. Closer to 0, the lower the amount of friction. So earlier I mentioned an ice cube, slide it along linoleum floor. Try that at home. It's fun. It's good, clean fun. Fun for the whole family. Get everybody. Yeah, get together. Family bonding. Throw ice cubes across the floor. That coefficient of friction would be down near 0. It might be like 0.05. However, something that's really important, a coefficient of friction that you use every time you drive. Rubber tires on asphalt road. Very important, don't you think? I do. When I'm driving down that road and I want to take that curve, I do not want to keep going straight. I want that friction to help me. That number is way up near 1. It's up here. It's 0.92. So that is rubber tire on asphalt road or asphalt highway. And that's dry road. This is dry road. If you have rain on the asphalt, it actually drops down the coefficient to about 0.6. And that's on a wet road. All right, we're going to talk about why that is. So, all right, before we do, we got a lot going on here. So you didn't know there was so much to friction, did you? Well, now you know. Sliding friction gets a coefficient symbol. Sliding friction, a coefficient symbol of a little k. Okay. Okay. Funny. Starting friction gets a coefficient of an S. Kinetic starting or starting. All right, so those are your two symbols you will see. Usually we're dealing with sliding friction. Usually for sliding friction is something moving along, and since we have motion, we will get the sliding friction. Okay, it's usually the one we're dealing with. Not always, but usually. Okay, so get this out of the way. I need some room. So much friction. I didn't know friction was so awesome. All right, let's go back to the tires. Some of you at this point might be thinking, well, wait a minute. Wait, you said 0.92 for rubber tires on asphalt. Yeah, well, what about my brand new Michelin tires, huh? I got brand new, and you see the tread on those babies. I mean, that's definitely gonna be higher than that. We're gonna be like closer to 0.99, right? Oh, and the tires I replaced were those bald tires. I didn't pass inspection, so they made me go get new tires. And so those bald tires must be, right down here lower, like 0.5 or something, right? No, wrong, All rubber tires on asphalt, dry asphalt, will have a 0.92. Then why did I go out and buy new tires? Why did they not pass me in my inspection? Because of the tread. Well, doesn't the tread make more friction? No, it doesn't. It's about the materials. It's about the materials. What about surface area? Because sometimes you have like small tires. I've seen people when they get a flat tire and they change it and they put those little toy spares on. They're driving down the road at the highway like 93 south at 90 miles an hour. That's really stupid. Get away from those people. Those tires aren't meant to handle that. We'll describe why in a minute. Well, don't get so angsty. Calm down, okay? It doesn't make a difference what kind of tire. Firestone, Goodyear, they all use the same rubber compounds. There's no difference in the rubber compounds, statistically speaking, so they all get this value. Well, why do I have tread on my tire? Answer me that, smart guy. Well, think about weather conditions. What's the tread designed to do? It's designed to push the water out of the way from the tire so you don't hydroplane. Yes, you learned that in driver's ed, hydroplaning. Let's talk about that. What is hydroplaning? Here's your asphalt highway. I made it super bumpy just to exaggerate it and make my point. Now it's raining out. What does the rain do? Right, super bumpy is more friction. The rougher something is like sandpaper, the higher the coefficient. If you have super bumpy highway, well, you've got a high coefficient. But then it rains, and then what happens? The rain fills in, the water fills those cracks in and makes it more smooth. I just can't help it whenever I say the word smooth. I gotta say it like that. I know it's kind of creepy, I know, sorry. So what did it do? That reduces the friction. It's not as rough anymore, smooth. All right, I'll stop, I promise. So that has something to do with it. So the materials are not only what the actual stuff is made out of, but also how sorry, I told you I'd stop. That something is. Now here's something interesting, very interesting. If you were to graph friction, okay, I'm gonna make a graph. This is going to be, I guess, I'll put roughness down here. And the amount of friction here. If we're to graph this, if you have high amounts of roughness, so it's bumpy, so the greater the bumpiness, the greater the friction. Okay, so the greater the bumpiness, the greater the friction. And you know that, you do too. Ice is very smooth. Okay, I won't do it. Okay, yeah, it's that, which means it doesn't have a lot of friction. Sandpaper is not that, and has a lot of friction. But here's something that's interesting. If you have, I'm gonna change my graph just a little bit down here. If you have things which are so smooth, I just couldn't do it, I couldn't resist, then what happens is the friction actually starts to go back up. So at this end of my graph, I will actually have high amounts of friction with things which are super, think of this when you were in biology class. Okay, you've got a glass slide to put something on, like you're going to look at a paramecium or something. And you take one of those cover slips, okay, glass, or glass plastic, both very, and you put it on top, you accidentally drop it where you don't want to, try to get it off. It's like, oh man, the heck, it's like sticky. Well, why? Because those two things are so that the molecules are right up against each other. And then you start getting what's called intermolecular forces, intermolecular bonds, a little chemistry, but it actually increases the amount of friction. If you get things too rubbing against something else, which is very kind of cool, huh? All right. So glass on glass would be a case like that. If you take a piece of glass, put it on top of a piece of glass, it's kind of like it sticks. Okay. One more thing here. I know this video is getting long. There's so much of friction. I bet you never knew how much fun you could have with friction. Oh, just wait. We're just getting started. All right. One more thing. Earlier I mentioned, somebody driving down the highway at 90 miles an hour with a little toy spare on. No, don't do that. It says do not drive over 55. I can't drive 55. Sammy Hagar, number 1984. Sammy Hagar, I can't drive 55. I can sing. I got skill. Where was I? Oh, yeah. And what about race cars? Well, I'm a NASCAR fan. I'm a NASCAR. I see those NASCAR tires are really wide. So clearly, the real wide tire will give you more friction than the small, thinner tire. That's why you have really wide tires. That's why. More friction. Wrong. What? Okay, 2 reasons why you have wide tires with auto racing. They go fast. Very fast. Much faster than you or I can or should be going on the highway. Therefore, they generate a butt ton, and that's a lot, a butt ton of heat. You generate a lot of heat, you need a large surface area to dissipate that heat. Otherwise, you will blow that tire. It will do. That's why in the little toy spare, you don't go 55. The thing will go, and you'll, bad. The other reason is for stability. They go around corners, and it does help them a little more stability with the wider tires for the car. So, yeah, we're going to wrap this up right now with friction. These are the ifs, ands, or buts about friction. We haven't done any calculating with it yet. We talked about what causes it, the different types of friction, how to reduce friction, the friction equation, what's important in the friction equation. Oh, and one more thing. This is usually going to be weight. Usually this is your weight vector. If you drive a rear-wheel drive vehicle in New Hampshire in the wintertime, you know that ain't very fun. Unless you put a lot of weight over the rear axle. Like maybe you have a pickup truck, you put a bunch of weight, sandbags or something over the rear axle, it gives you more friction. So therefore, we know that weight does increase your friction. The more something weighs, the heavier it is, the harder it is to get it started, and the harder it is to keep it going. Why? Because it deforms the surface it's on. This is your surface. Here's your box on a table, a very heavy box on a table. Now, of course, I just completely exaggerated that to show you that if you want to push this thing, you're going to have to actually push it through those molecules. Good luck with that, okay? Heavier objects do cause more friction. And with that, we'll call it a video.